if you've been watching the news about the time that I filmed this, you've heard about a new Tetraquark that is the X2900 with a mass about 2.9 GeV per c squared. So I thought I'd come here and explain it in Onium Theory and say that no, there's not any need to have tetraquarks in order to explain this. In fact, you don't need quarks at all. And this particle is said to decay to a D-meson and a K-meson. So we can simply model it as a D-meson orbited by a K-meson with relativistic orbital energy. And for those not familiar with the Onium theory, it's based on the idea that goes back to a solution by Milne, Feynman, and Sternglass that electrons and positrons can form relativistic positronium. When an electron and positron rotates at relativistic velocity, there's a temporary solution where they're stable, where the centrifugal force is opposed by the Coulomb force. And the relativistic positronium happens to have the mass energy of a neutral pion. So if you use this basic idea and extend it through all the particles, you can build a theory of particles that doesn't require quarks and can only needs electrons and protons to explain all the known particles and resonances. So in this case, we could have a D-meson orbited by two kaons. And what they start with is a B-meson. In an Onium theory, a B-meson has two D-mesons. In the base state, one of the D-mesons may be in a reduced energy state where it's a stationary kaon orbited by a relativistic kaon, which gives it slightly lower mass energy. And then that can decay to a psi 3770, which also decays to two D-mesons. And to get that energy, you can think of it being a D-meson orbited by two kaons, with the two kaons forming another D-meson. So it's essentially two D-mesons in nested orbits or co-located orbits, however you prefer to think about it. And then from there, if it loses a kaon, you can get the new X2900. And that comes in two varieties, the X0 2900 and the X1 2900, because they have slightly different mass, about 50 MeV. So one, from eyeballing the chart, looks like it's more like 2850, while the other one's around 2900. And so we can use this model to explain the mass. When we look at a D-meson with two kaons in orbit, they typically have a mass energy that's quantized at 70 MeV per c squared per particle, which gives us a total relativistic mass energy in the D-meson of 980.36 MeV per c squared. Now, if you only have a single kaon in relativistic orbit, you get half that, around 490 MeV. So if you take the mass of a D-meson, a kaon, and 490, you get about 2850 MeV per c squared, which explains X0 2900. Now there's also a strange D-meson, which has slightly higher energy than the base D-meson by around 100 MeV. And so that gives us another DK orbital solution that has a mass of about 2950 MeV per c squared. And so if you superimpose the 2850 and 2950, you could produce a peak at 2900. And so I think they should relook at the data considering these as the two main suspect particles and see if they can refit the data that way. Now, it might be possible in the Onium model that there's another particle at 2900, but I haven't worked through the ideal model for how that would be achieved yet. But I'm fairly confident it can be achieved. And it's also interesting that if you say, okay, there's a D orbited by a K, isn't there a K orbited by a D? Well, of course there is. And it's the D-mesons that are about 2460 MeV per c squared. And there's a neutral one, charged one, and strange variation. that are all about 2460 MeV per c squared that appear to be a kaon orbited by a pair of kaons forming an outer DeMeson. So these 2460 DeMesons actually have the same composition as the X2900, which makes us question, why do you have to give it a different quark composition when it has the same composition internally to begin with? It's just a different excitation state of the same thing. Anyway, I hope you enjoyed the video. If you did, please like, share, and subscribe. And if you want to learn more about Onium Theory, I have a book, Goodbye Quarks, the Onium Theory, that explains it in much more detail. And I also have 2 books on quantum field theory that you can read if you want to learn more about my quantum field theory research. And I'm an independent researcher, so by buying a book or contributing to my Patreon account, linked below, then you contribute to my research. And remember to think critically about what you read in the media. The first paper out on the subject is not always accurate. So thanks for watching.